Okay, let me give you an overview of getting the from the kinetic description to the fluid description. So pretty much taking the fluid moments. So here's our kinetic equation, which is the Boltzmann equation. The phi, we define phi n as v1, v2, all the way to the vn for the purpose of taking moments. We define the average as a distribution weighted average. Sorry, I integrated phi f over the integrated f. So we define the nth order moment of fs as such, integrated of fs phi n, and based on the definition of average, we know that the nth order moment also can be equal to ns phi n average, because this integrated over f essentially is the density. So we can take infinite amount of the moments, but let's just talk about first three moments which have a relatively significance in terms of physics. The first moment is basically integrated through velocity on both sides, because this essentially is one. So after the integration, we'll end up having a continuity equation. So d rho dt plus del v rho s equals to 0. So we don't have any source or sink, so the right hand side is 0. Of course, the continuity equation we check on Wikipedia, there will be another term which is expressed as a sink or source. The first moment we basically integrated through momentum, adding a momentum to it, so we ended up having this change of momentum equals to the change of the generalized energy and the pressure. The V average VI VK can be expressed as UI UK. UI UK is the U is the average velocity, which have the same definition as that. And there's also that's a general motion, and this is the WI WK, which can be interpreted as a thermal motion. Then it will give us pressure in a way. So this will be equivalent to PIK over ms. And there's our force, and this is a frictional force density. So this expression, in a nutshell, is pretty much the conservation of momentum. If we take the second order moment, we'll basically multiply integrated over kinetic energy. So we wound up having this expression. The P is the pressure, not the pressure tensor, which is the trace of the pressure tensor, trace of pressure tensor. So we have P in this expression is the half of the trace. And the pi in this expression is a stress tensor. Pretty much is the pressure tensor minus the pressure. And Q is a heat flux, which can be expressed in this way. You can think as the energy, the kinetic energy, the flow rate of the kinetic energy, as the flow rate of the heat. And this is the energy exchange density. So the second order in a nutshell can be considered as a conservation of energy. So the first three moments is the continuity equation, conservation of momentum, conservation of energy, which match with our expectation, of course. And we can take pretty much infinite amount of moment, but we'll need to create a certain closure or truncation to solve the set of equation, which I may talk in the different videos. And there's a very useful articles online I will put on the description as well.